Hello everyone, so now we are going to start this one. Describe multicast protocol such as PIM and IGMP. So first of all we will discuss what is multicast. Okay, first of all we are going to discuss what is multicast. If you remember, when we start our syllabus CCNA, CCNP, we are saying we have the three types of traffic, that is unicast, broadcast and multicast. I hope you remember this one, but anyhow, even if you don't know, we will discuss from the scratch. Unicast means one-to-one. If you are sending something from one to one, that is nothing but unicast. If you are sending to everyone, even that guy is not interested, that is known as broadcast. If you remember, switch will do the broadcast. And we have multicast. Multicast means whoever is interested, they are only going to get that traffic. Okay, that packets. So that is a multicast. I hope you already know this one, but anyhow, I will show you. Example, if you see here, this is video server. Imagine you have YouTube or anything. They are forwarding the video. It will go to all the devices. It is going to all the devices. That is, we can say multicast. If they are interested, they will take. If they are not interested, they will not take. But before going to that one, what I can say, unicast routing. The normal till now whatever we learn, that is a unicast routing. We can say unicast means one-to-one. Generally, whenever we configure routing protocol in the router, what they are doing? They are checking. They are checking where they need to go. Okay, they are checking where they need to go and they will forward the traffic. And if we see broadcast router will drop the broadcast packet. Router is going to drop the broadcast packet. Already we know that one. If you remember, in CCNA we learned DSCP relay agent. Because DSCP packet is a broadcast, router is dropping, so we configure DSCP relay agent. So broadcast packet is converting into unicast and then it is forwarding. So now in simple, we need to remember unicast means one-to-one. Broadcast means one-to-many. Means all. Even if you don't want, you will get. That is broadcast. Switch is going to do broadcast first time to learn the MAC address. Then you have multicast. Multicast means if you are interested, then you will receive. If you want to send message from one source to one destination, we will call that one as a unicast. Okay, if you want to send message from one source to one destination, it is known as unicast. If you want to send message from one source to everyone, that is known as broadcast. What if we want to send message from one source to group of receiver? That we will use as a multicast. We will call that multicast. Multicast communication is a technology that optimizes the network bandwidth utilization. And multicast communication is a technology that optimizes the network bandwidth. As we told, it will optimize the network bandwidth, the resources, everything is going to optimize. And we are going to use the protocol. Which protocol? Internet Group Management Protocol, IGMP. This one we are using for layer 2. And we are using PIM. PIM is nothing but protocol independent multicast for layer 3. So for router, we will use the PIM. To configure the multicast on the router, we will use PIM. And for the switch, we will use IGMP. We will take one scenario so you will have more idea. Okay, let me draw one scenario here. I will take a small scenario. What I will say here, imagine we are sitting somewhere. Imagine you are sitting in your home. I have one switch here. This is a switch. This switch is connected to video server. Okay, video server. Imagine you are watching a movie here. Okay, this is your computer and you are watching movie or anything here. You have one more PC here. The other guy is also watching that one. I can say this is a host 1, this is a host 2, this is switch, and I have one router here, and this router is connected like this way, and it is having the, imagine this is a bandwidth of 30 megabyte, okay, MBBS. And after that I have one more router here. From this router it is connected again to switch, This is my switch, that is, imagine switch 2. This is router 1. This is router 2. And here again we have the PC1 or PC2. I can say this is a host 3. Okay, we use host 1, host 2, so host 3. And I will take one more PC here, that is a host 4. So what I am saying here now, in this scenario we have the video server here. So we are going to get the video from this server. It will come like this. It will go like this, and it will come to this machine, same like this. And same like that it will go here when we are doing a unicast. Okay, it will go here and then it will go to this machine, and also for this separate machine, this is again, it is going from here and it is going to this machine. Okay, so what we are happening, this is a unicast, 1-to-1. This guy is getting the same video, this guy getting the same video, this guy is getting same video, this one same video. They are separating, they are sending same video how many times? 1, 2, 3, 4, 4 times. For 4 PC they are sending same video 4 times when they are using unicast. If they are using unicast, they are going to forward the video streaming 4 times, same video streaming. So what issue we will have? Bandwidth. It will utilize bandwidth for same thing. You are sending same thing for 4 times. You are sending same thing for 4 times. Okay, you will say no problem, I am sending, no issue like that. But imagine here if it is consuming 6 Mbps for one PC. Okay, if it is consuming 6 Mbps for one PC, imagine if you have 200 PC here, then you excuse me. So what I am saying here, if I have 200 machine here, one machine is taking 6 Mbps. So 6 into, imagine not only 200, you can take maybe 5. So 30 here only finish. Okay. If you have 5 computer here connected, then 5 into 6, because one computer, imagine one computer is consuming 6 Mbps. Okay. And if you have 5 machine in this side, this link is not sufficient. You need to upgrade the link. So we have issue. Instead of doing that one, we can send in the multicast. If we send in the multicast, what we will have? We will send only one time. Whoever is interested, they will receive. Let me repeat again. I am saying that one. I have video server, and video server is sending the video by using unicast. And in this side, if our what we can say, this side R2 side, we have 2 PC. One PC is consuming 6 Mbps. If you have 2, it will consume 12 Mbps. No problem, you have the link for 30 Mbps. But imagine if you have 5 PC or 6 PC, then you will have the issue. You need to upgrade your link. So this is not a good solution if we are using unicast for video streaming. To overcome these types of issue, what we will do? We will think, okay, this is the issue we have. So what we will do? We will do broadcast. Maybe you will think, I am using the unicast, so I am facing the issue. So let's do the broadcast. So imagine, let's see if we want to do the broadcast, what broadcast we'll do. Or let me take the different color so we can So this one, now we are doing broadcast. So broadcast will come here. Okay. It will go here. It will go here. When it come here, switch drop the broadcast packet. Sorry, router drop the broadcast packet. Video server is sending the video streaming by using broadcast. So it will come to switch. Switch will broadcast to all the ports. So this guy will also get that one. This guy also get that one. Example, this guy don't want, but he received that one. And here router will not forward. I will not forward. Router will say, I will not forward the broadcast traffic, because router is dropping the broadcast traffic. So we will have this issue. Okay. And this guy will say, I am not receiving the signal. I am not receiving the signal. And here router is dropping. Router is saying, I will not allow the broadcast traffic. So this we will have the issue when we are doing broadcast. Okay. For that purpose, what we will do, we will do the next one, that is a multicast. Okay, for that issue we have that issue, so for that purpose we will do the multicast. So when we are using the multicast, this guy will send, let me change the color here, let me take green. This guy is sending, so whoever is interested, they will receive this one, and it will come, example, this PC is interested, they will receive. So with the multicast, it will receive, but it is not easy. Multicast means we need to do some special configuration also. It is not like a out of box, like you will remove the equipment from the box and you will do basic configuration and you will install. It will not work. Okay, it will not work. So we need to do some configuration, because router will he will not understand who need the broadcast, and switch also not going to understand. So we need to do some configuration. We need to configure PIMP and IGMP. And if we draw the graph, example, if we see this is our host, okay, in the x-axis I am saying this is our host, in the y-axis I am saying this is the traffic. So if we do the normal way, in the unicast it will go like this. As number of hosts is increasing, we need to increase the speed also. Traffic also we need to increase, that is speed. Mbps we need to increase. If we use the multicast, even if it will remain constant, the speed will be remain same, because we are using the multicast. Even if you increase the host, this speed or the Mbps, traffic will remain same. But in the unicast way, whenever host is increased, we need to increase, because if your host is consuming 6 Mbps, if you have 2, it will consume 12, but if you have 40, it will increase 6 into 40. So like this way the graph will go this way in the case of unicast, but in the case of multicast it will remain constant. Okay, so now what we are saying, why we are using the unicast. So I hope now you have the idea. Example, if we use the unicast, we have the issue. If we use the broadcast, we have the issue. What is the issue? In unicast, you need to increase the bandwidth. In the broadcast, router will not forward the broadcast. Then we will go for the unicast. Then we will go for the multicast. So multicast IP, we have a range. If you remember, class D is used for multicast. Class D is used for the multicast. So this is the range of the IP 224.0.0.0 through 239.255.255.255. So this is a range in this one, but if you remember, we cannot use this one from here to here. This is used for the routing protocol. If you remember, EIGRP OSPF sending the updates hello messages by using multicast IP. So other than that one we are going to use. Okay, so some IPs are reserved. Example, this is for all hosts are reserved for this IP. All multicast router use this IP. This is unassigned. This is for DVMRP router is using this. OSPF is using this IP. DRBDR election is using this IP. ST router, ST host is using this. RIF version 2 is using this. EIGRP routers is using this. So DSCP server also using this. All PIMP router using this. So some are reserved, and the other one which is not assigned, unassigned, which is not reserved, we can use that one. Okay, so now let's see what component we need. Multicast, we are saying it is good, it is efficient, like no need to increase the bandwidth. We will send whoever is interested, they will take. But it does not work out of the box. Out of the box means like just you will remove from the box, install and do the basic configuration. It will not work. Okay, it will not work. So what you need to do, you need to do some configuration. You need to have some special configuration. Example, if you see here, this is our video server. He is sending here. And router, does anyone want this multicast traffic? Router is asking. Okay, does anyone want this multicast traffic? Then this guy is replying, I want to receive the multicast traffic. So he will send here. How he will send? Because he need to reply, he need to say that one. So if you see this scenario, what we are saying here, whenever video server is sending, the host need to reply. If we see here, we need some mechanism on our host that to tell the router when they want to receive the multicast traffic, and we use the IGMP, that is Internet Group Messaging Protocol. For this one, hosts that want to receive the multicast traffic will use the IGMP protocol to tell the router which multicast traffic they want to receive. In simple, just you need to remember, whenever our router is going to receive the traffic from the video server, router is asking who need this one, this is a multicast traffic. So our host need to reply to them. So our host is using IGMP protocol, Internet Group Management Protocol. What this protocol will do, host will reply with the help of this protocol to router saying that I am interested. So depending upon that reply, router is going to forward to that interface. Okay, so we can say here IGMP help the router to figure out on what interface it should forward the multicast traffic. Okay, so this one is good. We are saying how we can forward. So video server is sending to router is receiving, he is asking, and then host is replying him by using this protocol IGMP. So this guy reply him and he will forward to that particular interface, he will receive. This is a no problem. But issue if we have switch in between. But the problem, how about the switch? Example, if you have this scenario, this guy will reply here, but how about the switch? On what interface should I forward this multicast traffic? Switch is receiving and switch is asking where shall I forward this one? This guy is saying I want to receive. So what we will do here, switch is going to listen the IGMP messages. Router know that it need to forward the multicast traffic to the host by using the IGMP. We are using our host, our computer is using IGMP to tell the router I am interested. Okay, once the multicast traffic arrive at the switch, we have another problem. What another problem? Because switch don't know anything where to forward. So switch learn the MAC address by looking the source address of the Ethernet frame. As switch is working in the MAC address, he will learn the MAC address, but this is a broadcast traffic is coming. Since we use the MAC address only for the destination, how switch support to learn where to forward the multicast traffic to it? So what we will do, we will use the IGMP snooping. The switch will listen to IGMP message between the host and router to find out where it should forward multicast traffic. So what we are saying, this guy is saying, do anyone need this multicast traffic? Who is saying? Router. So this PC is replying, yes, I need. So switch is in between. He is with the help of IGMP snooping, he is listening the conversation between the router and the host, and he know that one this guy is available where. So with the help of that one, he will forward the traffic to that particular interface. Okay, so what we can say, switch will learn and they are going to forward. So with unicast routing, each router advertises directly interface connected. So generally whenever we are forwarding the traffic, we are configuring the OSPF, EIGRP like that. That is a unicast traffic. We can say unicast routing protocol. But if we want to forward the multicast traffic, we need to configure the multicast routing protocol. So we have that one DVMRP, that is distance vector multicast routing protocol. And we have MOSPF, multicast open short path first. And we have the PIMP, that is protocol independent multicast. So these three routing protocol we can use for the multicast routing. Generally we are using this PIMP. Okay. And now let's see IGMP. We are saying IGMP group messaging protocol. The PC is using this one and asking the router, I want to get this multicast traffic. So we are going to see this one. So that is nothing but Internet Group Management Protocol. It is a protocol that receiver used to join the multicast traffic. That is our host want to join, our computer want to join. So he will send that one. He will use that one, asking that router, I want this multicast traffic, and he will send and he will get that one, the traffic. And we have three version, IGMP version 1, version 2, version 3. So this version is the old version, rarely used. This one, IGMP version 2, is most commonly used in the multicast network. And this one also, so sometime we use this also, the IGMP version 3, which is used by SSM, that is source specified multicast. So this is a different protocol. So let's see version 1 what we have here. Version 1, whenever we want to get the traffic, our computer is using IGMP protocol. So version 1, first version, the host can use to announce to the router that they want to receive the multicast traffic from the specified group. It is a simple protocol, only 2 messages they are using: membership report, membership query. So what I am saying, our computer is using this protocol. We have the version here, version 1, version 2, version 3. This is the older version. Nowadays we are not using. The upgrade version of this one is a version 2. So we are using version 2. With this one, our PC is going to send the request to router saying that I need, and they are using these 2 messages: membership report and membership query. So when host want to join the multicast group, it will send the membership report. So our computer will send the message membership report. So he will join that one and he will receive that, what we can say, the traffic, the multicast traffic. And then router is going to periodically send the membership query message, and then again the PC will reply and they will make the membership. Like there is a expiry time, so before expiring they will communicate each other, and if they are saying yes I need, it is going to refresh that timer and that PC is going to get. If PC is not replying, then they will stop sending the traffic. If you see like this way, this guy will send here and he is going to forward this way. Okay, and this is the protocol which we are saying, IGMP 2, IGMP 3. This all are using by our computer, version 2, version 1. But the special thing is here, router is also using. And this IGMP snooping is nothing but the switch is using this one to learn the communication between the host and the, example, this host and the router. Whatever they are communicating, switch is going to learn with the help of IGMP snooping. And depending upon that one, he is going to forward the traffic. Just now what we discussed. And multicast routing protocol, we told we have 3 types, but one is mostly used, that is PIM. PIM is nothing but protocol independent multicast. So here in this one we have 2 types of mode. We have the typically PIM sparse and we have the PIM densy mode. So we have these 2 modes in that one also. Whenever we are configuring, we can configure this any one mode, densy mode, and the other one is a sparse mode. So if you see here, you will get the difference between these 2 modes. This is our multicast source. Okay, this is our multicast source, and that is a video, or we can say our server, whoever is broadcasting, whoever sending the video. And if you see, it is sending to all interface. It will send to all interface. Even if you don't have the receiver, you will get the traffic. Who is sending this one? This protocol, densy mode. If we configure the multicast PIM in densy mode, he is going to forward the traffic. He is going to forward the video streaming in all the destination, even if you don't need. Okay, and if we go for sparse mode, in that one they are going to forward only particular mode where we need. Example, this computer, if you see this scenario, this is our multicast server. Multicast server is sending here to the router, and this PC is asking I want to join that one by using IGMP. PC is using IGMP protocol. He will send information to router. This router is sending here and he is getting that traffic and he is going to forward. Example, it is simple. It is coming here like this way, and this guy is asking I want to join. So this request go like this way, and then this router will send only for this PC, like this, only for this PC. Okay, this one is known as sparse mode. And if you see another mode, that is densy mode, in that mode they will just broadcast, they will just send the traffic in all the interface. This is the difference between these 2. And we don't have the configuration, but we can do How we will do means I can show you sample, but as per the Cisco we don't have configuration. They are just asking the what we can say like a theoretical concept only. Just you need to know what is multicast, what are the advantage of using this one, what are the disadvantage, like that only. And if you want I will show you. Let me show you just how we can enable. This is a high configuration router, so let me take the any other router just to show you. I can use any router, maybe I will use this one. Just I want to show how we can configure. Okay. But we don't have the configuration in our syllabus. Okay, let me see. I can open any one router just to show you. Let me open this, and I will take the console of this router. It will take some time, let it load. So what I will do, first of all let me check show IP interface brief. We have IP here. No, we don't have IP. Just for sample purpose I am assigning one IP. Fast Ethernet 0x0. I will write here example IP address 192.168.1.1 255.255.255.0, and then I will write here no shut. Okay, what I done, just I put the basic IP address, basic IP configuration I put. After that what we can do, we want to enable that one, the multicast. So we need to write, first of all I will write here how we will enable. We will write IP multicast routing. Okay, like this command used to enable that one. First we will write this one, what we can say, enable multicast routing globally on the router. We use this command. After that we will go to the interface where we assign IP. We want to enable that one. So I will I just now I assign F0x0, so I will go there. I will write IP PIM. Okay, if you press question mark there is a lot of options. So which one we are going to use? We can use any mode. Example, if you want to use DEN mode, SPAR mode, if you see DEN mode is available. Okay, so this way DEN mode I can press enter. So I am saying which protocol they need to use. This way we can enable. After that we can start the config, what we can say, sending the traffic depending upon which video streaming we are using. So we use these two commands. First we need to remember this one to enable the IP multicast routing, and then which mode we want to run. Okay, so this is just basic. First we need to enable globally, that is IP multicast routing globally we need to enable. Then go under the interface where you want to enable that one. So go under the interface and enable that one. So if you want to do all the interface, we can enable to all the interface. Okay, so but we don't have any configuration, just I shown you two step. After that we have other thing also, but we don't have in our syllabus, so we will not do. Just theory you need to understand here, this one. Okay, so let me stop. This is just theory. If you see here, multicast protocols such as PIM and IGMP version 2 version 3.